Let's start by opening up a new file. We shall rename the model BeamFrame. Let's create a new part. We'll name this part Frame. The modeling space is 3D since it's a three-dimensional frame. The type is deformable. And we're going to set the base feature to point. When we created the barbell stand, we used a solid as the base feature because that was a three-dimensional solid. And for the truss structure, we used wire as the base feature and immediately sketched out the truss using wires. But this time we're going to go with point so that Abaqus can create a reference point for us, and we can use that as a starting point to start drawing out the rest of our beam structure. Essentially, using point helps us to create a part without actually putting anything in it, and then we can work from that point on. And then once we have that part created, we can then create the rest of the beam frame inside of that part container. And we'll set the approximate size to 20. Abaqus prompts you to enter the coordinates of the point. We're going to set it to 0, 0, 0, which is the origin, and then hit the enter key on your keyboard. You notice that Abaqus creates a point which appears in the viewport as an X with the letters RP next to it because it's a reference point. And so we've got a part, but the part is only a reference point, and we can now create the rest of the structure around this reference point. Now our beam frame consists of two frames, two two-dimensional frames connected by a cross bracing. So we're going to start by creating one of those frames. To do this, we're going to use datum points and lay those down in the parts module and then sketch out the frame using those datum points. We need to use the create datum point offset from point tool. This tool might be hidden behind the create datum point enter coordinates tool. So keep your left mouse button pressed down on that, and that should reveal the rest of the create datum point tools. Abaqus prompts you to select a point from which to offset. We click on our reference point and then type in an offset of 13 meters in the X direction. If the newly created datum point is not visible in your viewport, you can use the AutoFit View tool. Similarly, we create two more datum points by offsetting from the reference point. Next, we're going to use the Create Datum Plane using 3 Points tool. This will allow us to create a datum plane using the 3 datum points that we've just created, and then we can sketch out the frame on that datum plane. Abaqus prompts you to select the first point, then the second, and then the third. That'll make up the datum plane. We're going to select the 3 points in a counterclockwise direction so that the normal to the plane points out of the screen toward us. And this will help orient the sketch in a way that's easier for us to work with. If you were to select the points in a clockwise direction, the normal to the plane would be flipped, so it would be going into the screen, and that would flip our sketcher when we try to sketch the frame. Once the 3 points have been selected, Abaqus creates the datum plane. You may not see it at first because your viewport's not big enough. Using the AutoFit View tool should help. Now we need to sketch on this plane, but in order to create a sketch, Abaqus is going to ask us what plane we want to sketch it on, and to also select a datum axis or a line That helps us orient the plane before we sketch on it. You'll understand what I mean in a moment. For now, let's go ahead and create a datum axis. We'll use the Create Datum Axis Principal Axis tool. This allows us to use one of the principal axes, basically the X, Y, or Z axes, to draw a datum line. We'll go with the Y-axis. Abaqus goes ahead and draws a datum line on your screen, corresponding to the Y-axis. Now it's time to sketch the frame. We're going to use the Create Wire Planar tool. Abaqus prompts you to select a plane for the planar wire, and this is why we created the plane in the first place. So hover your mouse over the edge of the plane, and when it lights up in red, click on it. Next, Abaqus asks you to select an edge or axis that will appear vertical and on the right. We're going to use the drop-down to change it to vertical and on the left. And then we're going to use the datum axis, or the datum line, that we created just a moment ago. So now you see why we created the datum plane and the datum line. It was basically to give us a surface on which to sketch. Abaqus now puts you in the sketcher view with a grid. We'll use the Create Lines Connected tool to draw our frame. I'm going to zoom in using the scroll wheel of my mouse so I can see the datum points better. Go ahead and sketch the frame. Notice that Abaqus automatically constrains the horizontal line segments with an H, indicating that they're horizontal, and the vertical line segments as vertical. So we didn't have to create that constraint on our own. We're going to need to split up some of the line segments to create the individual beam members, and for that we're going to use the Split tool. It might be hidden behind the Auto Trim tool. Next, we're going to use the Add Dimension tool to dimension the frame. We'll use the Add Constraint tool to create equal length constraints for beam members that are of the same length. Once the sketch is complete, you can hit the Done button. Now we're going to create the other frame. Once again, we're going to need to create a datum plane on which to draw that frame. But this time, to create a datum plane, we're going to use the Create Datum Plane Offset from Plane tool, which basically allows us to use our current datum plane to create a new one by offsetting a distance from it. Abaqus prompts you to select the datum plane from which to offset, so go ahead and click on our datum plane. It then asks how we want to specify the offset, so we're going to enter a value. Abaqus draws an arrow on the screen to show you the direction of the offset, but since we're looking at it in 2D, it's a little hard to see which direction this arrow is pointing, whether it's pointing into the screen or out of it. So I'm going to use the Rotate View tool to see it a little better. And once I've rotated it, I'm going to click again on the Rotate View tool to exit out of it. If the arrow is pointing in the opposite direction from which we wanted to offset the plane, we would click the Flip button, and that would make the arrow point into the screen. Click on OK, and then we're going to give it an offset of 1.5 meters. Abaqus creates a new datum plane, offset 1.5 meters from the old datum plane. Once again, we're going to create the datum points using the Create Datum Point Enter Coordinates tool. Notice that the x and y coordinates of these datum points are the same as the previously created ones, but the z coordinate is 1.5, which creates the new datum points on our new datum plane. Again, we'll use the Create Wire Planar tool to sketch the frame. We'll select the new datum plane, and for the edge or axis that appears vertical and on the left, we're going to use our originally created datum line. It's going to be hard to see our new frame sketch over the old one, so I'm going to rotate the view a little bit. Now we'll use the Create Lines Connected tool to draw the frame. We'll dimension it using the Add Dimension tool. And we'll use the Split tool to split the line segments up into individual beam members. We'll also use the equal length constraint as required. Click the Done button to exit the sketcher. We now have the two frames. Notice that both the left and the right frame were created as the same part. Next, we're going to create the cross bracing as a separate part. Once again, we'll go with a 3D deformable part with a point as the base feature. We set the coordinates of the point to the origin, and Abaqus goes ahead and creates a reference point. We'll create the nodes of the cross bracing using the Create Datum Point Enter Coordinates tool. Type in the coordinates for the datum points. I've got them typed out in a notepad file, so I can easily copy and paste from that. Once we've got all the datum points created, we can use the AutoFit View tool to see them a little better. To create the cross braces, we're going to use the Create Wire Point-to-Point tool. In the Create Wire feature window, we're going to set the add method to disjoint wires as opposed to chained wires, which is selected by default. This is because our cross brace members are not connected to each other. Click the Add button to create the first wire. Abaqus asks you to select the first point. You might have to use the Rotate View tool so you can tell which points are on which frame. Abaqus prompts you to select the first point and then the second one, and it then creates a wire feature connecting them. Continue the process to create the other cross brace members. Once you've created all the members, click the Done button. You see that Abaqus has populated a table with the first and second point of each wire feature. At a later stage, we're going to want to select all of these wire features as one block, so it makes sense to go ahead and create a set at this stage by checking off the Create Set of Wires option. I'm going to go ahead and save my work at this point. Next, we're going to create the material.